नमस्कार विद्यार्थी मित्रो, मॅथमॅटिक्स पार्ट फर्स्ट मधील फोर्थ चॅप्टर पेअर ऑफ स्ट्रेट लाइन्स आपण आज या व्हिडिओमध्ये सुरुवात करणार आहोत। आपण 11th मध्ये स्ट्रेट लाइन चॅप्टर पाहिलेला आहे। त्याच्यामधील सर्व बेसिक कन्सेप्ट्स आपल्याला इथेही लागणार आहेतच। तर फर्स्टली आपण ते रिवाइज करू अँड देन पुढे जाऊ। बघा, आपण सुरुवात केली होती slope पासून। So the formula of the slope, first formula for the slope is by using its inclination, that is m is equal to tan theta. The second formula for the slope, whenever its 2 points are known, a x1 y1 and b x2 y2, which are on the line segment, then its slope is given by the formula y2 minus y1 upon x2 minus x1. In the same way, one more formula for the slope is there when its general equation is given. Whenever we know the general equation of the line, that is ax plus by plus c is equal to 0, then the slope of the line is given by the formula minus a by b. So we have the equations of the lines also in the various forms. So there are various forms of the equations of line. First is the slope point form. The second one is the 2-point form of the equation of line. The third one is the slope intercept form of equation of line. Then the double intercept form of equation of line. In the same way, we have the parametric form of the equation of the straight lines. Also, we have seen in the 11th the angle between any two lines, that is the acute angle, is given by the formula tan theta is equals to modulus of m1 minus m2 upon 1 plus m1 m2 whenever the slopes of the two lines m1 and m2 are known. In the same way, we have the formula for the distance of a point from the line. Also, we have the formula for the distance between the two parallel lines. हे तुम्ही सर्व आर्टिकल्स 11 च्या बुक्स मधून रिवाइज करावे। तर आपण 12th साठी जे फर्स्ट आर्टिकल आहे त्याच्याकडे वळतोय। द फर्स्ट आर्टिकल इज 4.1 कंबाइंड इक्वेशन ऑफ द पेअर ऑफ लाइन्स। सी, every equation, every straight line is associated with its equation. बघा, प्रत्येक स्ट्रेट लाइनला त्याचं इक्वेशन असतं। And the general form of equation of straight line is ax plus by plus c is equal to 0. It is a general equation which is the first degree equation in the two variables x and y. Also, we know that by the chapter locus that every point on the locus, that is every point on the line, satisfies its equation, and we also know that every point which satisfies the given equation, it lies on that line whose equation is given. So here in this article we are considering a combined equation of pair of lines. means इथे आपल्याला काय बघायचं आहे, दोन स्ट्रेट लाइन साठी एक सिंगल इक्वेशन आपल्याला मिळेल, ज्याला आपण काय म्हणतोय, combined equation. Also, it is known by the other word, the joint equation. So we have the formula for it. Let's see what is this. So we have given the two straight lines, and in short we are using the letters as the u and v for these expressions. See, the first general equation of the straight line is the a1x plus b1 y plus c1 is equals to 0 is the first line, its equation. Let this as a u is equals to this expression, means u is equal to 0 is the first straight line. Then second equation, let us take this as a a2x plus b2 y plus c2 is equals to 0. If these are the two lines, u is equal to 0 and v is equal to 0, then the combined equation of these two lines is given by the formula u v is equals to 0. The combined equation is given by the formula u v is equal to 0, means the u is the a1x plus b1y plus c1, and the value of v is the a2x plus b2y plus c2, and that is equals to 0. So if we take this product and simplify this equation, then we get the equation which is known as the combined or joint equation of the two straight lines u is equal to 0 and v is equals to 0. So with this article we have a theorem related to this. In that we have to prove that the equation u is equal to 0 represents the two straight lines u is equal to 0 and v is equal to 0. So see the statement of the theorem. See the statement. The equation uv is equal to 0 represents the combined equation of the line u is equal to 0 and v is equal to 0. So first consider the two lines in the plane. Let this as the u is equal to 0 line whose equation is u is equal to 0. Consider the second line whose equation is a v is equal to 0. बघा हे आता कसं प्रूव्ह करता येईल. सो आपल्याला माहिती आहे की एखाद्या लाईन वरती एखादा पॉइंट आपण घेतला तर त्या पॉइंटच्या कोऑर्डिनेट्सनी त्याचे इक्वेशन सॅटिस्फाय होतं. सो आता आपल्याला प्रूव्ह काय करायचंय, तर uv इज इक्वल टू 0 हे u इज इक्वल टू 0 चं सुद्धा इक्वेशन आहे आणि uv इज इक्वल टू 0 हे v इज इक्वल टू 0 या लाईनचं सुद्धा इक्वेशन आहे. म्हणजेच आपण काय प्रूव्ह करणार आहोत, u इज इक्वल टू 0 या लाईनवरच्या सगळ्या पॉइंट्सनी uv इज इक्वल टू 0 हे इक्वेशन काय झालं पाहिजे, सॅटिस्फाय झालं पाहिजे. इन द सेम वे आपल्याला काय प्रूव्ह करावं लागेल, v इज इक्वल टू 0 या लाईनवरच्या सगळ्या पॉइंट्सनी uv इज इक्वल टू 0 हे इक्वेशन सॅटिस्फाय झालं पाहिजे. म्हणजेच आपल्याला काय म्हणता येईल, तर u इज इक्वल टू 0 हे u इज इक्वल टू 0 अँड v इज इक्वल टू 0 या दोन्ही लाईन्सचं कंबाइंड इक्वेशन आहे. याउलट आपल्याला आणखीन हेही प्रूव्ह करावं लागेल की एखादा पॉइंट जो हे uv इज इक्वल टू 0 हे इक्वेशन सॅटिस्फाय करणारा असेल तो एकतर u इज इक्वल टू 0 या लाईनचा पॉइंट असावा किंवा v इज इक्वल टू 0 या लाईनचा पॉइंट असायला पाहिजे. सो आपण कोणती केस इथे यूज करतोय, अ पॉइंट विच लाईज ऑन द लाईन इट सॅटिस्फाईज इट्स इक्वेशन. आणि या आर्टिकल मध्ये आपण काय करणार आहोत, त्या थेरम मध्ये याचा यूज करणार आहोत. सो सी द प्रूफ. सो मला याच्यासाठी या u is equal to 0 या लाइन वरती एक पॉइंट चूज करावा लागेल. सो वी आर चूजिंग ए आर्बिट्ररी पॉइंट p whose coordinates are x1, y1 and also we are choosing the point from the line v is equal to 0, that is q. So let us take the equations of u is equal to 0 and v is equal to 0 in the general form. First let u is equals to a1x plus b1y plus c1 is equal to 0, the equation of the first line, and v is equals to a2x plus b2y plus c2 is equals to 0 are the two given lines. Let p x1 y1 be the point on the line u is equals to 0. Therefore, it satisfies the equation of u is equals to 0. Therefore, p x1 y1 satisfy the equation a1x plus b1y plus c1 is equal to 0, which is the equation of u is equal to 0. Therefore we get, instead of x and y, we are using x1 y1. Therefore a1 x1 plus b1 y1 plus c1 is equals to 0. Let this as the equation number 1. Now we have to prove that this point also satisfies the equation u is equal to 0. So consider the equation u is equal to. Consider u is equal to, by putting x as x1 and y as a y1. So u is a a1x plus b1y plus c1, and v is a a2x plus b2y plus c2. And for the point P, x1, y1, now these are the x1, y1, x1, y1. And now this term is in the equation number 1, whose value is 0. So therefore from 1 we can say that it is 0 into this a2 x1 plus b2 y1 plus c2. And so finally this will be 0. This means that the equation u is equal to 0 is satisfied by the point P x1 y1, which is from the line u is equal to 0. Therefore P x1 y1 satisfy the equation u is equal to 0. And the point P x1 y1 is an arbitrary point. This means that every point from the line u is equal to 0 satisfies the equation u is equal to 0. Therefore we can say that every point from u is equals to 0 satisfies the equation u is equals to 0. In the same way, we have to prove that every point on the line v is equal to 0 also satisfies the u is equal to 0. And by the same way we can do this. Instead of this 0, this will become 0. And so u is equal to 0. So we state this as a similarly. Similarly, we can prove that every point on the v is equal to 0 also satisfies the equation u is equal to 0. And now we have to prove that a point which satisfies the equation u is equal to 0, that lies either on u is equal to 0 or v is equal to 0. So let us take a point, third point R, which satisfies the equation u is equal to 0. So let R x dash y dash, which satisfy the equation u is equals to 0, and therefore the u into v, u with this point x dash y dash, u is the a1 x dash plus b1 y dash plus c1, v a2 x dash plus b2 y dash plus c2, that is equals to 0. But from this we can separate these two equations, a1 x dash plus b1 y dash plus c1 is equals to 0, or a2 x dash plus b2 y dash plus c2 is equals to 0. And these are the equations of the lines u is equal to 0 and v is equal to 0. And this means that the point r x dash y dash satisfies the equation u is equal to 0 or v is equal to 0. This means that r is on the line u is equal to 0 or v is equal to 0. Therefore, the point r x dash y dash is on either line u is equal to 0 or on v is equal to 0. And so, we can prove that every point which satisfies u v is equal to 0 is on u is equal to 0 or v is equal to 0. As this is chosen as an arbitrary point, we can state this for any point. Therefore, every point which satisfies the equation u is equal to 0 is on either u is equal to 0 or v is equals to 0. And therefore, we can say that every point from u is equal to 0 satisfies u is equal to 0. Also, every point from v is equal to 0 satisfies the equation u is equal to 0. And every point which satisfies the equation u is equal to 0 is on either u is equal to 0 or v is equal to 0. So, you can say that this equation u is equal to 0 represents the lines, combined equation of the lines u is equal to 0 or and v is equals to 0. And so, we get the statement of the theorem. The equation u is equal to 0 represents the combined equation of the lines u is equal to 0 and v is equals to 0. See one or two examples on the joint equation or combined equation. The first example, say what is, find the combined equation, or we can say that it as a joint equation of the following pair of lines. First equation, x plus 2y minus 1 is equal to 0 and x minus 3y plus 2 is equal to 0. So, we have given the equations of the two lines. Let this as the first u is equal to and this as a v is equal to, and just take only its product. And this will be the combined equation. Let us start the solution. Let u is equals to x plus 2y minus 1 is equals to 0 and v is equals to x minus 3y plus 2 is equals to 0. The combined equation of u is equal to 0 and v is equal to 0 is given by the equation u is equals to 0. Therefore, the value of u, x plus 2y minus 1, and the v, the x minus 3y plus 2 is equals to 0. Just take the product. X into x, x square, x into minus 3y, minus 3xy, x into 2, plus 2x, 2y into x, plus 2xy, 2y into minus 3y, so 3 6 minus 6 y square, 2y into 2 is the 4y, then minus 1 into minus x plus 3y minus 2 is equals to 0. Now collect the terms. X square, the single term, therefore it is x square, minus 3xy plus 2xy is a minus xy, then minus 6 y square, in the term of containing x, 2x and minus x plus x, then plus 4y and plus 3y plus 7y, and the last, the constant term is the minus 2 is equals to 0. This is the required combined equations of given lines. Okay, so अगदी सोपं आहे. Whenever the equations of the two lines are given, so we are treating just as u and v and taking the product term. This will be the joint equation. U is equals to 0. So now see the example when these two equations are not given. So second example here it is find the combined equation of the lines which are passing through the point 2, 3. The point 2, 3 is the common point from the two lines and the lines are perpendicular to the lines. 3x plus 2y minus 1 is equal to 0 and the second line x minus 3y plus 2 is equals to 0. Means the lines whose joint equation is to be found out, these lines are passing through the point 2, 3 and from that one line is perpendicular to this line and the other line is perpendicular to the second given line. So that these are the u is equal to 0 and v is equal to 0. So we have to find out the equations of u is equal to and v is equal to first and then we have to join this u into v. You see, for this purpose we need the equations of various forms of lines and one common point from the two lines is given. So we can use the slope point form. For this purpose we need the slope and the slope. बघा इथं आपल्या ज्या दोन लाइन्स आहेत ते या दोन लाइन्स ना पहिली लाइन हिला परपेंडिक्युलर असेल आणि दुसरी v is equal to 0 लाइन या सेकंड लाइनला परपेंडिक्युलर असेल. So we know the relation between the slopes of the perpendicular lines. So what is this relation? So if the slope of the first line is m1, slope of the second line is m2 and if these two lines are perpendicular to each other, then product of that slope is minus 1, that is m1 into m2 is equals to minus 1. Whenever the two lines are perpendicular to each other, then product of the slope of the two lines is minus 1. Means if one slope is known, then other can be calculated by taking the negative reciprocal of this. Okay. So by using this, and these two are the equations in the general form, so we can find the slope of these two lines by the formula minus a by b, and if slope of this line is known, then by taking negative reciprocal we get the slope of the first line u is equal to 0. By the same way, finding the slope of this minus a by b formula and taking the negative reciprocal of this, we get the slope of the v is equal to 0. So we get the slopes of the two lines and one common point is here 2, 3. So we can find the equations of the two lines by using the slope point form of equation of line. So let us start for the proof, for the solution. So let u is equals to 0 and v is equals to 0 be the two lines which are passing through the point 2, 3 and are perpendicular to the lines 3x plus 2y minus 1 is equals to 0 and x minus 3y plus 2 is equal to 0 respectively. Means the line u is equal to 0 is perpendicular to this line and v is equal to 0 is perpendicular to this. So now slope of the line first line 3x plus 2y minus 1 is equal to 0 is by the formula minus a by b means minus coefficient of x divided by coefficient of y minus 3 by 2. Now by taking negative reciprocal of this, we get the slope of u is equal to 0. Therefore slope of the line u is equal to 0 is, let us say the m1 is equals to negative and reciprocal is a 2 by 3. Similarly, we find the slope of this and then slope of u is equal to 0. And slope of the line x minus 3y plus 2 is equal to 0 is again by the minus a by b. It is 1 by 3. Therefore, the slope of line which is perpendicular to this line, that is v is equal to 0. V is equal to 0 is m2 is equal to negative reciprocal minus 3. And now we are using the slope point form. What is the slope point form of equation of line? That is y minus y1 is equal to m into x minus x1. If the x1 and y1 is the point from the line and m is the slope of the line. So this is the slope of the u is equal to 0, the point. Slope of the v is equal to 0 and the point. Therefore, the equation of the line u is equal to 0 is, you can say that here by slope point form. Slope point form y minus y1. I am writing here, it is the formula is equals to m into x minus x1. So what are the x1 and y1 now? Treat this as the x1 and y1. x1, y1. So y minus y1 is the 3 is equal to slope of the u is the 2 by 3 into x minus x1 is the 2. Just simplify this equation to the general form. Multiply by 3. It is 3 into y, 3y minus 3, 3, 9 to 2x minus 2 to 4. So it is 2x minus 3y plus 9 minus 4 is the plus 5 is equals to 0. Is the equation of u is equal to 0. Now the equation of v is equal to 0 is again by the same formula y minus y1 and x1 y1 are the same. So y minus 3 into the slope of v is equal to 0 now. Slope of v is equal to 0 is the minus 3 into x minus x1. x1 is a 2. Let's simplify this again. Minus 3x plus 3 to 6. And plus 3x plus y minus 6 minus 3 is the minus 9 is equals to 0. These are the equations of u is equal to and v is equal to. So now let u is equals to 2x minus 3y plus 5 is equals to 0 and v is equals to 3x plus y minus 9 is equals to 0. Therefore, u is equals to the combined equation is given by the combined equation is u is equals to 0. So u 2x minus 3y plus 5 into v 3x plus y minus 9 is equal to 0. Let us take the product. 2x into 3x 6x square plus 2x y minus 18x minus 3y into this minus 9xy minus 9y square 9 3 27y plus 5 into 15x plus 5y minus 45 is equal to 0. Let's simplify this. So 6x square plus 2xy minus 9, it is minus 7xy minus 9y square minus 18x 15x plus 15 minus 3x in the term containing y 27y and 5y plus, so it is 32y in the constant term minus 45 is equals to 0 is the required joint equation of the lines passing through the point 2, 3 perpendicular to these two lines. सो या व्हिडिओ मध्ये आपण स्टार्ट केलेला आहे. या चॅप्टरचा हा फर्स्ट व्हिडिओ आहे. तर फर्स्टली आपण जॉइंट इक्वेशनची फॉर्म्युला बघितलाय. जॉइंट इक्वेशन ऑफ द लाइन u is equal to 0 and v is equal to 0 is a uv is equal to 0. त्याचा थेरम आपण प्रूव्ह केलेला आहे and the two examples for the joint equations. See, this equation is known as the joint equation of the two lines u is equal to 0 and v is equal to 0. And conversely, these two equations are known as the separate equation of this. Means the equations u is equal to 0 and v is equal to 0 are known as the separate equations of the equation uv is equal to 0. And while solving the problems, you can observe that the highest degree of this joint equation will be the 2. So we are going to next article, that is homogeneous equation of degree 2. That is in the next video. Okay, thank you.